The next few examples are all from the logic chapter, and I'm going to go ahead and talk a little bit about negation of statements first, and then we'll get into truth tables. So we are asked to write the negation of the quantified statement. Um, these statements all here, notice that they have all, some are not, none. So these are involving the existential and the universal quantifiers. So a good way to do the negations of those, so I draw a little rectangle, and let me try this one more time. Draw my rectangle, there we go. And I'm going to start off here with, all of them. And then I'm going to bump it down a little bit to some are. And then it's going to be some are not. And then it'll be none. The negations will be on the opposite corners. Okay, so the negation of an all will be some are not. The negation of some are will be none are. Okay, so like they just work in pairs like that. Okay, so coming up here to question number 1, we're told that some petunias are flowers. So I'm going to write some P's are F's. So what's the negation of this going to be? Well, the negation of some, so the opposite of some, is over here is going to be none. So this is going to say none or no P's are F's. So no petunias are flowers. So that would be choice D. No petunias are flowers. Okay, so that was number 1. All right, so number 2, we're given all athletes are famous. So I'm going to write down all A's are famous, so are F. And so what's the negation of this? Well, the negation of an all is some are not. So I'm going to say some A's are not F. So some athletes are not famous. Some athletes are not famous. So that would be letter choice C in this case. Okay, so how do I write the negation of an if-then statement? Okay, so if you think back about the truth table, when you're filling out your truth table, and we said, well, the conditional, the if-then is only going to be false. So it's false when you have true implies false. Okay, so that's how I remember it. So that means the true, the first part is true and the second part is false. So the negation of P implies Q is going to be P and not Q. So P happened, but Q didn't. So P and not Q, that's the negation. So when I come over here and I have the statement, if I am in Acapulco, so if I am in A, then I am in Mexico. So I'm going to let M represent that statement. So the negation of A implies M is going to be A and not M. So A happens and not M. So I am in Acapulco and I am not in Mexico. So I am in Acapulco and I'm not in Mexico, letter choice C. So the main thing, like I said, you've got to know this equivalency, but the if-then statement, the negation is not an if-then statement. It's the and. So the first part happens and the second part did not follow. Okay, so number 36, these deal with De Morgan's laws, and on the test I may or may not say use De Morgan's laws. So what if I just said write the negation of the statement? Okay, then you need to know you use De Morgan's laws to write the negation of the statement. Okay, so we need to know two equivalencies, and they're very similar to each other. So if I want to know the negation of P and Q, that's going to be not P or not Q. And then the negation of the disjunction P or Q is going to be not P and not Q. So I have students say, oh, you distribute the negative. You can think of that way if you want to. Just remember that both parts are going to be negated, and then the and the or will switch. So because what happens with the P and Q, the only time that P and Q is true is when both of them are true. So to make that fail, I just need to have one or the other fail. So that's why it's not P or not Q. So as long as one of the others doesn't happen, then the whole statement will be false. Again, that's just one way to help you kind of remember it. All right, so coming over here to our example. A man runs across the street. So I'm going to say a man runs across the street and he does not get hit by a car. And it's up to you. You can let H be not hit by a car, or you can write it as not H, however you prefer. But I'm just going to go with H for not hit by a car. So the negation of this statement is going to be not R or not H. So not R is the man does not run across the street, or, and the negation of not hit by a car would be is hit by a car. So a man does not run across the street, or he is not hit by a car. I'm sorry, or he is hit by a car. All right, so a man runs. Okay, I just said all that wrong, didn't I? Okay, let me go ahead and I don't know what I was thinking here. So let me go ahead and just back this up for a second and say that again. I know I wrote the right things, but I'm not sure what came out of my mouth. So, all right. Okay, so a man runs across the street and he does not get hit by a car. So a man runs across the street, that's going to be R, and he does not get hit by a car. So I'm going to let it be does not get hit by a car. So that's going to be my H. So the negation of this statement will be not R or not H. So R was a man runs across the street. So not R is a man does not run across the street. And then not H, remember H was he's not hit by a car. So the negation of that is he does get hit by a car. So reading it out one more time now. So a man does not run across the street, or he does get hit by a car. So this is going to be letter choice C. Okay, the next couple examples are going to deal with truth tables and truth values. So truth tables, if it's a multiple choice question, it's really important that you first look to see how they set up their table, the order of the variables. Usually I'll go ahead and just do them, in alphabetical order, but like I said, if you have to match their table, you want to set yours up in the same order of the variables. So the other thing that we have to do is decide how many rows we have. Now when you have two statements, then you'll have 2 squared or 4 rows. If you have 3 statements like S, Q, and P, then you're going to have 2 to the 3 or 8 rows. Okay. If I happen to have 4 statements, then 2 to the 4, I would have 16 rows, but I'm not going to give you one that high. Okay, so setting up our truth table, remember I'm going to have 8 rows, and for each of these, they're going to have to be half true and half false. You want to have a systematic way of listing them. And again, if it is a multiple choice question, look at the order they have those in. That's what you have to match. Okay, and if it's not a multiple choice question, do it any way you want, but make sure you have half true, half false, and that you list all 8 possibilities. Okay, so let me go ahead and start with my columns. I've got S, and then I'm going to have Q, and then I'll have P. All right, so when I'm setting this up, I'm going to do, starting with S, I'm going to do half trues, so I'm going to have 4 trues, and then 4 falses. Okay, now for Q, again, half these have to be true, half false, so I'm going to come up here and do 2 trues, and then 2 falses. And then I'll do 2 trues, and 2 falses. And then for my last one, I'm going to do true, false, true, false. So true, false, true, false, true, false, true, false. So I think it's a good way to, I would set up all of them this way. But like I said, we do get all the possibilities. Okay, so now when I am working on my truth table, I got to figure out, how do I want to create my columns? There's a couple different ways to do this. I'm going to show you one. I'm still going to do all the steps. I'm just going to write it in a more compact way. So what I do is I will go ahead and write out my statement. So I want to know what, I'm trying to find what S or not Q and P is. Okay. So before I can figure this out, I said, well, I got to start inside the parentheses. So the first thing I'm going to do is figure out what, Q and P is. Once I've got that, I can figure out what the negation of Q and P is. I already know what S is, but that would be my third step. And then the very last thing I do is the disjunction will be the or. So when I start this, I'm going to come down here and I'm going to do my Q and P first. So when I'm doing Q and P, again, I'm looking at these two columns right here. With the and, it's only true if both of them are true. So I have true and true, that'll be true, true and false, so this will be a false. Next one, false and true, so this will be false, false and false will be false. So true and true is true, true and false is false. And now I have false and true, and false and false. Okay, so now I've got my Q and P. So moving over to the next one, I need to find the negation of Q and P. So it's just going to be the opposite truth values. So again, now I'm looking at this column right here and I'm taking the negation. So this becomes false, true, 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 false, true, and then true, true. If I had something, that other than just S here, like a not S or another statement, then I would work it in here. I don't normally rewrite it, but like I said, if you wanted to rewrite it just so that you have it kind of close by, we can. So I'm just copying down what we had for S. So true, true, false, false. I'm sorry, true, true. Oops. True, true. And then false, 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 false. Okay, and again, that's just, making it easy for me to see the two columns together. Okay, so now I'm ready for my last column. Like I said, this is going to be my final answer, this disjunction. So the or, what's the truth value for the or? We said, well, as long as one or the other is true, then the compound statement will be true. So true or false is true. True or true is true. True or true is true. True and true. Then I have a false or false, so that one will be false. Then we have false or true. That's going to be true. And then the last two are also true because these are true. Okay. There are some little shortcuts you can take with the truth tables. They don't save you a lot of time, but the thing that you absolutely need to know are all the truth tables. So make sure that you know that for the or, the and, the negation as well, the if then, and the if and only then, if and only if. So you need to have those memorized. Otherwise, you really can't do the truth tables. Questions number 15 and 16 ask us to find the truth value of a given compound statement. The difference between a truth value and a truth table, the truth table you have to do the entire table. With a truth value, I only care about the value in a given circumstance. So like here we're told that P is a true statement and Q is going to be a false statement. So like I said, I don't care about the whole table, I just care about that one instance. So what I like to do is I'm going to go ahead and replace the statements down here with their truth values. So I'm going to work at number 16. So for number 16, I've got the negation of, and then our square brackets, the negation of P. Well, P is a true statement, so I'm going to say, I'm just going to go ahead and put my true in there. Or, and then parentheses, not Q. So not, Q is a false statement, so I'll put not false, and P is a true statement. And then I will work this out. Make sure that you start inside your parentheses first. So like I said, I'm going to go ahead and start in, I'll make sure I work this out first before I worry about this or. Okay, so working, so I got the negation of, and then so the not T here by itself, I can change that to a false, or, and then my parentheses, they have a not false, so it'll be true and true. Alright, so now I have the negation of, false, or true and true is a true statement. And now inside my square brackets, I've got false or true. So again, with the or, as long as one or the other is true, it's true. So false or true is a true statement. And so lastly, the negation of true is going to be a false statement. So this will be false. Okay. So again, do not do the whole table, just do for that one instance. Number 17 is similar to the last example, except for we have more statements. So now we're told that P represents a true statement and Q and R are both going to be false statements. Okay, so same as we did the last time, I'm going to start with my not. I have square brackets, parentheses, not P, so I'm going to say not true, and Q, which is false, so I'll put in F false for Q, and then or R, and then R is false statement as well. Okay, and then I'll just start working these out. So again, like I said, make sure you work kind of inside out. So this not I will do last. So inside here I've got not true, so that becomes a false, and then and false or false. And now this false and false, that becomes a false. So now I have false or false. A false or false, that's going to be false. And my last step, the negation of false, is true. So the overall statement is going to be true when P is true and Q and R are false. Number 19 is very similar to the previous two examples. The difference is they don't give me the values, the truth values for the statements P and Q. I have to figure those out on my own. Alright, so like I said, you can think of this as being, I'll go ahead and write it over here. So I've got P is going to be the statement 4 plus 7 does not equal 13. And I'm going to let Q equal the statement 8 times 5 does not equal 45. So what's the truth value of P? So we said, well, 11 does not equal 13. Well, that's a true statement. 11 does not equal 13. And over here for Q, I have 40 does not equal 45. That is also a true statement. So I'm going to go ahead and plug in true for both P and Q. So if I rewrite this statement, symbolically, so 4 plus 7 does not equal 13, that's going to be P. If and only if, so that's our biconditional. 8 times 5 does not equal 45. That represents the statement Q. So I've got P if and only Q. And P is a true, Q is a true. So this becomes true if and only if true. And then the truth table for the biconditional says, well, this will be a true statement then. And so just a quick reminder, the biconditional is true when P and Q have the same truth value. So both true or both false. Let me go ahead and I'm going to kind of add on to this. Let me go ahead and change the second statement. Okay, so let me go ahead and say P is still going to be 4 plus 7 does not equal 13. So that's going to be, like I said, we already decided that was going to be a true statement. But suppose I change Q. So suppose Q, let me use a different variable. Suppose R is the statement 8 times 5 equals 45. Well, 40 equals 45, that is a false statement. So I would use false for R. So now again, going up here and rewriting it, I would have P if and only if R. P's truth value is true. R's truth value is a false. So now I have the statement true if and only if false, and that will be a false statement. Okay, so like I said, this is just like the other ones, except for you have to figure out the truth values for your P, your Q, your R, whatever you're given. Okay, the next two examples use an Euler diagram to determine whether an argument is valid or invalid. Okay, so remember the Euler diagrams way back when we were doing sets and we had Venn diagrams. We just use them to sort of represent the relationship between these sets. Okay, and so just a quick reminder over here. If we have all P's or Q's, so that means all P's are Q's, that means the set of P's is inside Q's. So that's all P's or Q's. Okay. If I have some, so here's some P's are Q's. So P's and Q's, and if it's some, that means I got at least one thing in the overlap. If I say some are not, so again, they're overlapping. Maybe they overlap, maybe they don't. But if I say some are not, that means I got somebody over here that is definitely not in Q. And then none, that means there can be nothing in common between the two sets P and Q. So that one would be none. Okay, so coming over here to our argument. Also, when you are working with arguments, determining whether they're valid and invalid, it's best to ignore the conclusion. Just work with the premises. The idea is if the conclusion follows from the premises, then it's a valid argument. Whether the statements are true or false is irrelevant. It's just, is the argument a good argument? So I'm going to go ahead and, like I said, use symbols to represent these. And I only work with the premises. So my first premise, all rock stars are performers. So that means the set of rock stars has to be inside the set of performers. Okay, so all rock stars are performers. Okay, my next premise is Meg is a performer. So where does Meg go? Well, Meg has to be inside performers. But is she here or is she here? No, I don't know. All I know is that she has to be inside the set of performers. She may be inside R, she may not be inside R. So I'm going to draw Meg as a question mark. So that's what my picture is. That's the two premises. That's what my argument is based on. So my conclusion, therefore Meg is a rock star. Well, is Meg guaranteed to be in Rockstar? No. So that's why this is an invalid argument. She may be one, but it's not based on this argument. Okay, so like I said, don't use your knowledge. If you know Meg, you know she's a rock star. That's irrelevant. We're trying to really determine if the argument is a good one. For question number 44, we are given another argument. We're trying to decide if it's a good argument or not. Right? Okay, so my first premise, all birds have feathers. So the set of birds has to lie inside the set of, creatures with feathers, feathered creatures. So birds is inside feathers. Then I'm told that no mammals has feather. So that means the set of mammals has to be somewhere where it does not touch feathers. So I'm going to let this be my mammals. So this is no mammals have feathers. And then my conclusion is, like I said, so my picture is this. I cannot add anything else to my picture. That's based on the two premises. So now the question is, does my conclusion, is it forced to follow? So therefore, no mammals are birds. Well, this is true because mammals are over here and birds are over here. If birds are inside feathers and feathers and mammals don't touch, these two aren't touching. So this is going to be a valid argument. And like I said, again, it doesn't matter if it's true or false. We're just evaluating the argument used to get there.